Incremental readings. So before digging into incremental reading, we'll have just a very high-level overview of what incremental reading is, the algorithm, how it works. It's a lot simpler this way. So first is that, hey, wait. Before incremental reading, we start with space repetition because incremental reading is a superset. So a short review. Space repetition is not used to determine intervals for articles. Articles is passive review. It's your learning material. So this is not affected. Is scheduled? Yes, but not using space repetition. This only affects flashcards. Then articles are spaced in time with increasing intervals. And you could say, what? This is still true for a space repetition. Yes, they are spaced with increasing intervals, and this is where what they have in common ends. We won't enter into how they are scheduled. Well, we will do later on in the course, but not now. So incremental reading is not just for flashcards. It's for also articles. Articles means any passive reading. Can be videos, books, whatever. So incremental reading, at a very high level, is a process of breaking down knowledge into manageable parts. So I have knowledge, or web knowledge, information on websites, books, or whatever, and I chunk this down, which eventually it will become knowledge for me. There's an analogy. Imagine that incremental reading is a meat grinder for web knowledge. You say, I have this article, I have this poem, this medium article, this book, I put this, and I chunk all of the meat. So the input, so everything, the sources I want to read from, and then the output are stable memories into my brain. Then, how incremental reading works in a high-level perspective. I have articles and I split into smaller portions. I can repeat this several times, it's not just one. So perhaps I split or chunk down, and this chunk down, I chunk down again different times, multiple times. Then each portion that I extracted or I split has its own priority. Everything has a unique priority. It's like a queue. There cannot be two elements on the same place on the queue. So this is from one source, but what I could do is then another source, I will chunk it down, and they will have different priorities. So if I sort by priorities, I will have chunks of different sources, different articles. So portions compete based on priority. Spacing and intervals are secondary. Exactly. So the passive material, so what you're going to read, listen, or watch, is they compete by priority. What's more important, relevant? They have intervals, yes, but this is secondary, unlike in space repetition. Then this also implies that you have, if there are intervals, that you have interruption and all of that. But we will keep just the general perspective. Then balancing the learning process. Intervals for unprocessed articles increase over time. To why? To keep daily cues shorter and randomly shuffle articles to avoid over-prioritizing new ones. You want to avoid the recency bias. So you're mixing content you already have with content that is newer or just today, kind of randomly. It's semi-random at the end of the day. So you ensure that you don't forget what you have learned. So even if I always have something new to learn, I'm revisiting what I have learned some days ago, some weeks ago, some years ago, to keep it in my memory. Then, efficient learning tools, close relations. In incremental reading, it's meant to use close relations. So when you select any text, like in the image, let's say important, I select that word and I make an extract, I close relation, meaning that the word I selected becomes the answer. And everything else, the content of that topic, would be the question. It's indeed the most efficient way to create flashcards. So close relations in incremental reading are treated like other learning items. There's nothing special that, hey, that's not a question and answer, it's a close relation. No, it's the same thing at the end of the day. It's presented in a different way, but it's the same thing. And then those closed relations are mastered with the help of a space repetition. It's only that moment that the algorithm takes place with a space repetition. So, as I imported the article, I have this chunking down. I reprioritized. I chunk it down. Now I do the closed relation. Now I start with space repetition. I had increasing intervals, yes, but that was not space repetition. That's why we can say that incremental reading is a superset of space repetition, because it includes space repetition and more stuff. And then automation. Why? Because you highlight the important words, and with one click, you get the knowledge extraction. That, hey, I generated the flashcard with question and answer as a closed relation. And what are the steps? So I have the meat grinder, so I just keep adding articles. I could just be adding animals, let's say, articles, this. Oh, I like this, I want to read that, bam, bam. Then I just keep reading. Like I keep grinding, I keep reading, da 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 da. And as I keep grinding or reading, I just say, hey, that's important. That's more important than this. I don't say it's important. I say how important that is. How important that is. Hey, I want that. I extract. With an extract, I indicate Supermemo that it's knowledge I want to remember. Hey, there's something here. Hey, I make the closed relation, and because I make the closed relation, I want to remember something, so this will be presented in a flashcard format, and it will be scheduled according to space repetition. But without all of the jargon, all of the things that happen behind the curtains, let's say, that's all I do. I just grind. I just keep telling what's coming out, the grinded meat, how important that is. Hey, I want to remember that. So I put all of the loading sources, and in the machine, I just reprioritize and extract and do closed relations. And what I have at the output are flashcards, closed relation flashcards, with set priorities of what I decided to remember. As easy as that. Incremental reading algorithm summary. Articles compete on priority. Space repetition helps master knowledge from closed relations. And remaining details are learned over weeks and months or even years. You start with the most critical knowledge, the most high priority, and then everything is diminishing returns. So conclusion. So incremental reading is the grinder, the machine. And a space repetition, let's say it's the glue that makes it everything put together, that sticks on your mind. Together, they ensure knowledge is retained and mastered efficiently over time. And that's the key difference, is if you use space repetition, like Anki or other software, but without incremental reading, you have the flashcards, but you don't have all of this meat grinder. It will be like if you have a knife and you do it yourself. To follow the analogy, how do you measure what you have read, what is pending? How you prioritize all of those chunks? You cannot. You could do it by source, but by chunks, there will be thousands. It will be impossible to do it manually. So you will need to do some other tools, some other software, and it will be always suboptimal. How do you track where it is? And on top of that, in incremental reading, you can read and recall. So you have articles you will read and prioritize, and flashcards that you will try to recall. That is called interleaving. This is not possible in other software. Because remember that recalling is part of a space repetition and is part of incremental reading. You do this every other rep or every 4 repetitions, something like that. And this works wonderfully. And this can only be done with incremental reading. So that has been the high-level overview of incremental reading algorithm. Hope it's more clear now with this analogy. There's a lot of nuances that we will see later on this course. But for now, that's enough. See you incrementally.